This is an example problem of calculating the density of an element, in this case indium, given its atomic radius in picometers and its lattice structure, in this case the FCC or face-centered cubic lattice structure. So the way we're going to approach this problem is recognize that we want to find density. Okay, so density is what we want to find. And what is density? Mass over volume. Okay, so what we want to know is what is the mass of indium in a given unit of volume. Well, our unit of volume is the unit cell. Okay, and we know that our unit cell is face-centered cubic, and therefore we can determine how many atoms of indium are within that unit cell, and from the atoms we can determine the mass, and that's the mass per unit volume. Okay, and the size of the unit cell we can know from the radius. All right, so that's the basic idea. Now let's do the calculation and see what we get. Okay, so first of all, let's go ahead and look at the face-centered cubic unit cell, and here I have a little model of it. Here are the corners of the lattice points, or the lattice points of the face-centered cubic, and here's the center face piece there. Now the actual unit cell, of course, is from the centers of the atoms, and so if we want to find the dimensions of this unit cell, we need to look at it in the diagonal. Okay, that's the point where these atoms are all touching. Okay, we can't go this way because we don't know what this distance is in between there. All right, so we do know this distance because here's 3 indium atoms, and we know the radius of the indium atom, 163 picometers. So there's 1, 2, 3, 4 times the radius of indium. That gives us the diagonal across the unit cell. Okay, so we have a little bit of you'll recall the Pythagorean theorem, where if you want to find this distance, and in our case this is a square, so that's the same there, and we have this distance, which is 4 times 163 picometers. All right, so let me just go ahead and calculate that out. 4 times 163 is 652 picometers. All right, so this distance is 652 picometers. The Pythagorean theorem tells us that for a right triangle, the square of the sides equals the square of the hypotenuse. Okay, so x squared plus the sum of those squares, the x squared plus this side squared, which is another x squared, or 2x squared, equals the hypotenuse squared, all right, or 652 picometers squared. All right, so let's go ahead and find the value for x, and we can take 652 and just multiply it by 652 to square it, and we get a large number there. That's this part. Now let's divide that by 2 and then take the square root. Okay, so divided by 2, and we want the square root of this, and once I find it on the calculator, here we go, square root is 461.0 picometers. All right, so x equals 461, and I'll go ahead and leave it with 3 significant figures there, picometers. All right, notice that we have picometers squared, but then we take the square root, so that comes back down to picometers. All right, so that is now the dimension of our unit cell. All right, that's this distance from the center to the center along here. All right, so now if we want the volume of this cubic unit cell, width times length times height, all of which are equal, and so we can take this number and cube it to get our volume. All right, now I would like to go ahead and express the density that we calculate in terms of grams per cubic centimeter. All right, so I'm going to convert this picometers to centimeters first and then cube it to so that I'll have centimeters cubed. I mean, you can do it either way, but I think it'll be a little bit more convenient this way. So picometer, a pico is 10 to the minus 12th, and centi is 10 to the minus 2. So we have a difference of 10 to the minus 10th here, or we can say there are 10 to the 10th picometers in 1 centimeter. Okay, remember that the picometer is the smaller one, so there will be a large number of the picometers in the centimeter. All right, so if we do this, the picometers will cancel, and we'll have 461 times 10 to the negative 10th, or I could put that in proper notation and say 4.61 times 10 to the minus 8th, okay, centimeters. So now let's calculate the volume, okay, which is going to be x cubed, which will be this value cubed. And if I do this, let me just take this number and do, oops, I had the wrong button pressed there, 4.61 exponent to the negative 8th, okay, and I want to cube this, and so on my calculator I have x to the y, and if I put in 3, that should give me that value cubed, and that looks right because we have negative 8. You cube that, that'd be multiplying this by 3. That'd be about 24, and it's close to that. So we'll go ahead with this 9.797, and this will be centimeters cubed. All right, so now I have the bottom part of my density equation. All right, the grams per cubic centimeter. Now I know how many cubic centimeters. Oh, of course, this is 10 to the minus 23. It's certainly not 10 cubic centimeters there. So I'll just cross this off and say times 10 to the minus 23rd cubic centimeters.